So now that we've talked about how to multiply polynomials, now what we're going to do is we're basically going to undo that process. So instead of looking at how do we take something and how do we take two polynomials and multiplying them, we're going to look at how do we take something that has been multiplied and write it as a product. So write it as a product of its factors. So this process is called factoring when you're undoing multiplication. So you're undoing the distributive property, you're undoing something that's been um, multiplied to get a polynomial, you're undoing that process to figure out what what two polynomials or what two binomials can you multiply together to get this expression. So the first type of factoring is called Gcf factoring, which really means factoring out the greatest common factor. So a couple definitions here. The greatest common factor for a polynomial is the largest monomial that divides each term of the polynomial. So it's a factor of each term of the polynomial. The next definition, the largest monomial, is the monomial with the greatest coefficient and the highest powers on the variables. So what we're going to do is we're always going to scan through and we're going to look for a number that we can factor out, and we're going to look for the highest powers on variables. So what are the variables that we can factor out? So when we look at this first example here, our first goal is to first figure out what is the greatest common factor. What can we factor out of each of these? What could I take out from both? So if I look at the 3x and the 15, I know I'm not going to be able to take out any variables because I don't have any variables in the second term. So I look at the numbers, and usually what I do is I look at the number, the smallest number in the situation, so in this case 3, and I ask myself, does 3 go into both terms? Well, 3 goes into itself, but 3 also goes into 15, which means my GCF is going to be 3. So that means I can rewrite this as 3 times some expression to get 3x minus 15. So if I'm trying to figure out what do I have to multiply 3 by to get 3x minus 15, I really need to think about it as dividing 3 from each of these pieces. So it's going to be x minus 5. When I divide each piece by 3, so the 3's cancel here, minus 15 divided by 3 is going to be negative 5. So what this means is I can rewrite this 3x minus 15 as a product of 3 and x minus 5. If I distributed 3 through with to x minus 5, I would get 3x minus 15. So that's kind of, we're undoing the multiplication to see what are the numbers that we would take the product of. So let's look at some other examples. So this example here, I first am scanning to find the GCF. So I always start by trying to find what are the numbers here that would work. So I look at the smallest number, which is 5. 5 goes into itself, and 5 goes into 15. So that means 5 is going to be the GCF. But then I want to look at my variables here. So I have an x to the third and I have an x squared. So the biggest thing that I'm going to be able to take out of both of those is going to be an x squared, because I can't divide by x to the third because I don't have enough x's over on the other side to divide it by x to the third. So now that I know that my greatest common factor is 5x squared, that means that's going to come outside of parentheses, because I'm going to be asking myself, what can I multiply 5x squared by to get the original expression? So I'm trying to undo the distributive property. So I'm going to divide everything by 5x squared. And my 5's are going to cancel. And whenever you have your exponents here, it's really just like subtracting them. So x to the third divided by x squared is just going to be an x. And then here I'm going to have 3, and my x's are just going to cancel. So it's going to be x minus 3. So x minus 3 is what you need to multiply the GCF by in order to get back the original. So again, to check, distribute the 5x squared, you would get 5x to the third minus 15x squared. So we know we've done it correctly. So let's look at another one. Here we want to factor out the greatest common factor. So again, look at the smaller number. So I look at the smallest number, which is 8, and I have to ask myself, can I factor out an 8 out of each term? And the answer is, well, you can factor it out of a 16. You can divide 16 by 8 nicely, but you can't divide 8 into 20, or you can't do 20 divided by 8 nicely. So we need to pick a smaller number because 8's too big. So think about numbers that go into 8. So right off the top of my head, I'm thinking of, okay, well, 2 goes into 8, and 2 goes into all of these, but there's a bigger number. 4 also goes into 8, and 4 would go into 16 and into 20. So that means my greatest common factor for the number is going to be 4. And then we have to decide on the variable part. I have x to the 5th, x to the 4th, and x to the 3rd. So the biggest thing that I'll be able to take out of all of them is an x to the 3rd. So that means I'm going to have one set of parentheses, 4x to the 3rd going outside of them, because I'm asking myself, what do I multiply 4x to the 3rd by to get this original trinomial? So I'm going to divide everything by 4x to the 3rd so I can actually see what would I have multiplied by to get 4x to the 3rd. So I'm going to divide everything by 4x to the 3rd. So here I'm going to get 16. So these are going to cancel. I get 4, and it's going to be x to the 2nd, because if you have 5 x's up top and you have 3 that cancel, there's going to be 2 left. Basically, you're just subtracting the exponents. And then I'm going to have a minus 20x to the 4th divided by 4x to the 3rd is going to give me a minus 5x. And your exponent's just going to be a 1, because 4 up top, 3 on the bottom. 3 of them are going to cancel. You'll be with 1 left. And then you divide your coefficients. So I get 2. 8 divided by 4 is 2. And these x to the thirds are going to completely cancel. So I'm left with this product here. And again, if you check, you should get what we started with to know that we've done it correctly. Notice too, when I divide, it's very similar to multiplying, where you actually divide the coefficients and you keep the base and subtract the exponents. When you multiply monomials, you multiply the coefficients, keep the base, add the exponents. So just keep that in mind. It's very similar. So let's look at one last example. Maybe I have two more examples. So factor the greatest common factor from this expression here. So again, we're scanning it. We're looking for 6, because 6 is the smallest number. And 6 does go into all of these. Then I look at my variables. I have x, and it's just going to be an x to the first that'll go in all of them. And this time I also have a second variable. So I look, and it's just going to be y. Y is the only variable. The y to the first is the greatest common factor between all of these. So I'm going to now take my 6xy. That's going to go outside of parentheses. And I'm asking myself, what would I have to multiply that by to get this original expression? So I'm thinking of it as dividing every piece by 6xy. Just make sure that you remember to put it as a product. Whenever you factor, your answer should be written as a product. It's asking you, what can you multiply to get back to the original? So it should be 6xy times something. So I'm going to look at what's going to cancel here. So the 6's are going to cancel. I'm going to have an x squared, and my y's are canceling. Then I'm going to have 18 divided by 6 is going to be 3. I'm going to have 1x left, and I'm going to have 1y left. And then here I'm going to have a 2 when I do 12 divided by 6. My x's are going to completely cancel, and I'm going to have y to the third over y, which means I'm going to be left with 2 y's up top. And here will be my final answer. Again, to check, distribute the 6xy through, and you should get the original expression. So last one with GCF, and then we're going to look at a different type of factoring. So for this one, again, scan through the problem, look at the smaller number, which is 3. 3 does go into all 3 pieces. Then I look at my variables. A, so the second is going to work because that's the smallest, so it'll go in all of them. And I'm just going to have to use B because B is the smallest, so that it'll go into all of the other variables. So then I'm going to write it as 3a squared b, have your parentheses, and we're dividing everything by 3a squared b. So I have my 3's are canceling, my a squares are canceling, and my b's are canceling. Keep in mind this is not 0. This means whenever you divide something by itself, you get 1. Most common mistake I've seen is that we want to write 0 there because they've all canceled, but it's really you're dividing something by itself, so it should equal 1. Then I go on to the next term. Negative 6 divided by 3 is going to be minus 2. I have a to the third over a squared, so I'm going to have an a left. B squared over b is just going to have a b. Then I'm going to have plus 3 when I do 9 divided by 3. A to the third over a squared. I'm going to have 1a left when I subtract those exponents. And I'm going to have b squared when I subtract b to the third minus, or when I do b to the third divided by b to the first, which means I'm subtracting the exponents. So that's it for that. And then let's look at another type of factoring. So another type of factoring is what we call factor by grouping, meaning when you look at this polynomial here, so xy plus 3x plus 2y plus 6, when you scan this entire polynomial, we do not have a GCF that works for the entire thing. However, if you split this and you look at this side over here, we have a GCF of x. And if you look at this other side, we have a GCF of 2. So what that means is we can do what we call factor by grouping, meaning we're going to take out the GCF out of 2 terms. Then we're going to take out the GCF of another set of 2 terms. And what we're going to do, so we would get this here. So if this is my polynomial split, I took an x out of the first, I took a 2 out of the other. Then what happens is we create this other common factor. We have a binomial that becomes a common factor. We have y plus 3 is in both terms. So then what we end up doing is we end up factoring that out as a common factor. And when you factor that out, so if you look, we factor that out, we were left with an x and a plus 2. So that's where this x plus 2 comes from. So that's what we're going to do. We're going to factor these by grouping. In order for this to work, you have to have 4 terms because it has to be able to be split evenly. So if you look, I scan this entire thing first, and I don't have a common factor between all 4 terms. And since I have 4 terms, that means I can think of this as splitting it down the middle and factor each individual piece first with the GCF. So this first piece here, I could factor out an x, so I'd be left with a plus b. So if I take each of these and I factor out an x, and then I have a plus, I'm going to just keep that sign. That's important to keep the sign here. And then the second piece here, I have a y that I could factor out. So I'm going to take and I'm going to factor out a y, and I'm left with a plus b. And now you can see that you have this common factor. So what happens is I can take that a plus b out. So if you imagine taking out a plus b, this is no longer here. So I'm left with an x. And when I take out an a plus b out of this piece, I'm left with a y, a plus y. So that's my final answer here. You don't need to actually scribble it out. I was just showing you how we're taking out, we're pretending that that a plus b is no longer there because we factored it out and it became right here. So I'm left with an x plus y. So let's look at some other ones here. So for this one, I scan it. I don't have a GCF that's between all four terms. However, if I split it, so if we split this down the middle, we have a GCF of a in this first set, so I could factor out an a. So I would have 3x minus 2 if I take and divide everything by a. And then I have a plus, and I could take and I could divide out a 5 by all of these. So I could take out my 5. So I would have 3x minus 2. And again, you have a common factor. In order for this to work, this factor here has to be the same. So that means I have to have the same binomial in order for this to work. So if you don't end up with the same binomial, that means either you're doing something wrong or it's a case where you can't factor by grouping. So now what I do is I take that 3x minus 2, I factor that out. When this is gone, the 3x minus 2, I'm left with an a. And when it's gone over here, I'm left with a plus 5. So then that's it. So that gives me my two numbers, or my two binomials, that are going to multiply to give me this expression. Remember, that's what factoring means. It means rewrite this expression as a product. So what things can we multiply to get this expression? So that's what we're doing here. We're trying to reverse the process of multiplication. In the previous lesson, you saw how to multiply these. Now it's how do we undo something that's already been multiplied. So let's look at just a couple more of these. So for this example, again, you're scanning it, you're seeing things that are similar but not similar in all of them. So I'm looking at splitting this in half, and I can take an x out of this first part. So I have 2x plus 5a. And then when I get to the second part, I see that I can take out a y. But there's also negatives here. I don't want to have a negative 5a left in my answer. I want it to be positive 5a because of this expression right here. Because I have 2x plus 5. So my goal is to get a 2x plus 5. So what I'm actually going to factor out this time is a negative y. Because by factoring out a negative y, it's going to make this a positive 2, and it's going to make it a positive 5a, which is what I want. I want it to be positive 2x plus 5a. So I'm going to factor out a minus y, which means I'm going to be left with a positive 2x and a positive 5a. And now you can do the step where you can factor out these pieces here, since they're the same. So I have 2x plus 5a. And when this is gone, that whole set of parentheses, you're left with an x, and you're left with a minus y on the other side. And it has to be multiplication between the x minus y and the 2x plus 5a because you're factoring out. You're taking out a GCF. This 2x plus 5a is really the GCF now. So since you're taking it out, you're undistributing it, you have to make sure it gets multiplied by the x minus y. And one last example. So we have, again, four terms, no common factor between all four terms, but if we split it, we see that we do have a common factor. Up top, or the first two here, I could factor out a 5. So I have 3 minus y to the 4th. And then for the second piece, I can factor out a 3 again. Actually, I can't factor out a 3 because if you look at, see how it says x to the 3rd, y to the 4th? I can't factor out a 3, but what you could do is I could factor out an x to the third, because if I factor out an x to the third, then what's going to happen is I'll be left with that 3 and that y to the fourth. So I'm going to factor out an x to the fourth, not x to the third. And if you look though, I want this to be a positive 3 and a minus y to the fourth. So that means I need to actually factor out a negative x to the third. So I'm going to factor out a negative x to the third, which means I'll have a positive 3 left and then a minus y to the fourth. You're just switching your signs. And now what this will allow me to do is factor out this 3 minus y to the fourth. And when you do that, you'll be left with a 5 minus x to the third. And then that's it for that. So it's really just taking a GCF out of half of the expression, and then you're forming this new GCF that works for the entire expression, so that you can undistribute that and get to a product of two binomials that will multiply to this 4 terms. So that's it for this lesson. And next time we will look at factoring trinomials.